Hi everyone, I am Whitroy. Welcome to this audiobook learning video.
Hi everyone, my name is John and I work alongside Whitroy as an electrical tutor.
In this video, we will introduce ASNZS 4836, which covers safe working on or near low voltage and extra low voltage electrical installations and equipment. Before we begin, I want to make something clear about this audiobook. This is not a word-for-word reading of ASNZS 4836-2023. The standard itself must always be read and followed exactly when you are doing electrical work or preparing for the EWRB exam. The official standard is the legal and technical reference. If there is any difference, missing detail, or possible mistake in this audiobook, you must follow the official document. What this audiobook does is take the key ideas from the standard and explain them in simple spoken language, the kind of language you can listen to while driving, working, or revising. It helps you understand what the clauses mean, why the rules exist, and how they apply in real electrical work. So please think of this audiobook as a learning companion, not a replacement for the actual standard. All right, let's get started.
Section 4. Risk Control for Specific Situations. Today we're moving into Section 4 of ASNZS 4836. This section is about risk control for specific work situations. Different hazards create different kinds of risk, so the control measures must match the real situation in front of you. Working near exposed, energized parts is different from working near batteries. Working around capacitors is different from working in a hazardous area. Working in a cramped ceiling space is different from working in a clear switch room. So before work starts, look at the equipment, the environment, stored energy, building materials, earthed situations, and anything else that may affect the safety of the job. Clause 4.1, General. Clause 4.1 explains that each hazard presents its own type and level of risk. The controls used for one job may not be enough for another job. Before work starts, several factors should be considered. This includes the equipment being installed, the environment where the electrical equipment will be installed, energy storage systems, building materials, and earthed situations. In simple terms, safety is not only about the circuit, it is also about the place where the work is done. For example, the same electrical task may become more dangerous if the area is damp, cramped, poorly lit, near earthed metalwork, or close to other live parts. So the controls must be chosen for the actual job, not just copied from a previous job. Clause 4.2, Safety Observer. Clause 4.2 explains when a safety observer is required. If the risk assessment shows that a safety observer is required, then the work must not be carried out without one. A safety observer has a very serious role. They must watch the work, warn the worker about danger, and stop the work if needed. For example, they may warn the worker about accidental contact with energized electrical circuits or equipment. They must not do another task that distracts them from observing the work. They must be able to communicate quickly and clearly with the person doing the work. They must be proficient in electrical rescue and CPR. CPR means cardiopulmonary resuscitation. They must wear the correct PPE. PPE means personal protective equipment. They must also have ready access to a rescue kit that is suitable for the task. A safety observer must also be able to perform the role properly. If a temporary or permanent condition affects their ability to observe, communicate, or respond, they should not be used for that role. In practical terms, a safety observer is not just another person standing nearby. They are an active safety control. Their attention must stay on the worker, the work area, and the electrical risk. Clause 4.3, Specific Situations. Clause 4.3 introduces the specific situations covered in this section. These include work on or near exposed energized conductors and live conductive parts, capacitors, hazardous areas, trafficable areas, areas of reduced mobility, lighting, batteries and DC supplies, high voltage producing equipment, induced voltage, asbestos, PCB materials, lightning, cutting cables, removing out-of-service equipment, and leaving work unfinished. Each situation has its own hazards. Each situation needs suitable controls. Clause 4.3.1. Work on or near exposed energized conductors and live conductive parts. Clause 4.3.1 explains work on or near exposed energized conductors and live conductive parts. The first safety message is very clear. Working on energized circuits and equipment is not as safe as working de-energized. So work on or near exposed energized parts should only be carried out in limited situations. It may only proceed where it is necessary in the interests of safety, or where de-energizing the equipment would create greater risk, and where the required risk controls have been carried out. The worker must be competent. In some workplaces, the relevant authority, employer, or organization may also require specific training and authorization before the work can proceed. Conductive items must not be used on or near exposed energized conductors or live conductive parts. This includes metal tape measures, metal rules, reinforced tapes, conductive ladders, elevated work platforms, scaffolding, and metal guards on portable lamps. Personal conductive items must also not be worn. This includes bracelets, rings, neck chains, exposed metal zips, watches, and similar conductive items. If earplugs or earmuffs are worn, they must not introduce a conductive hazard. A competent safety observer must be present when work is carried out on energized electrical equipment, unless the risk assessment shows there is no serious risk for the proposed work. Workers must be trained and competent in live work test procedures and in the use of test equipment. The risks include electric shock, electrocution, arc blast, and flash burn injuries. Before work starts, the risks must be assessed and documented. Isolation must always be considered first. This may mean rescheduling the work to a time when the equipment can be de-energized. If isolation or barriers cannot be used, a safety observer may be required as another control. Only a competent person may carry out the work. Precautions must be used to prevent simultaneous contact with conductors at different voltages. Precautions must also prevent contact between a live conductor and earth. Suitable PPE must be worn. The PPE must fit correctly and must be in good condition. All work on exposed energized conductors or live conductive parts must be done from a stable work position. If the energized electrical equipment has earthed metal, earthing continuity must be maintained. If earthing continuity cannot be maintained in the normal way, the work must follow an approved procedure. Temporary protective earthing conductors may be needed when an electrical component is separated from its normal earthed metalwork. Those temporary protective earthing conductors must be rated to withstand the prospective short-circuit current of the primary protection. Special care is needed with neutral connections. A test may first show a de-energized condition at a neutral connection. But when the neutral connection is removed, voltage may appear between conductors or between conductors and earth. That is why neutral conductors must not be treated casually. Where possible, only conductors at the same voltage should be worked on at one time. Insulating barriers, covers, or mats must be used between conductors of different phases or voltages in the work area. Another approved procedure may also be used where suitable. The conductive path between a person and a conductor, between a person and earth, or between two people must be broken. This may be done using insulating barriers, insulating covers, insulating mats, insulating tools, or insulating gloves. If the work is left unfinished, the workplace must be left safe for other people. When the work is complete, electrical equipment must be returned to service in its original state, unless the changes have been approved. Clause 4.3.2 Capacitors. Clause 4.3.2 explains the danger from capacitors. Capacitors can store a large amount of electrical energy. This stored energy may still be present even when the equipment has been de-energized. That stored energy may cause electric shock, electrocution, arcs, flash burns, or ignition of gas or solid material. Before work starts on capacitors or their associated circuit wiring, the capacitors must be proved de-energized and fully discharged. This may be done using suitable discharging devices or by following the instructions for use. The safe discharged condition must be maintained for the duration of the work. A voltage tester must be used immediately before work to prove that the capacitors are discharged. The voltage test must be done on the DC scale of the tester. DC means direct current. If a capacitor is not discharged, then the requirements for work on or near exposed energized conductors, or live conductive parts, apply. Care must also be taken when applying discharging devices because arcing can occur. Capacitor terminals must not be short-circuited or earthed using metal objects such as spanners or screwdrivers. That method can cause electrocution, arcs, flash burns, or electric shock. Only suitable devices should be used for the work. Clause 4.3.3 Hazardous areas. Clause 4.3.3 explains work in hazardous areas. A hazardous area is a place where flammable gas, vapor, or combustible dust may be present. Examples may include petrochemical installations, grain storage areas, and flour mills. Work on or near electrical installations or equipment in hazardous areas must only be performed using safe work methods suitable for that site. Normal work methods may not be safe in a hazardous area. A spark, hot surface, static discharge, unsuitable tool, or unsuitable electrical equipment may cause ignition. Workers may also need specific competency for hazardous area work, depending on the regulatory requirements and the type of work being carried out. In simple terms, hazardous areas require special control. Do not take ordinary tools, ordinary test equipment, or ordinary work methods into a hazardous area unless they are suitable for that area and the work has been properly controlled. Clause 4.3.4 Trafficable areas. Clause 4.3.4 explains work near trafficable areas. Trafficable areas include areas used by vehicles and pedestrians. When electrical work is carried out near traffic areas, traffic management procedures must be used where required. This may include screens, barriers, signage, and suitable lighting. Lighting should be installed for safety and protection where poor lighting has been identified as a risk factor. Extra care is also needed when working in passageways or narrow access areas. For example, a door may be opened unexpectedly and push a worker towards an energized electrical source. In that situation, the door should be restrained while the work is being done. In practical terms, the movement of people, vehicles, doors, and equipment around the worker must be controlled. The electrical risk is not the only risk. The surrounding movement can also place the worker in danger. Clause 4.3.5. Areas of reduced mobility. Clause 4.3.5 explains areas of reduced mobility. These are areas where a worker cannot move freely or escape easily. Examples include restricted areas around switchboards, ceiling spaces, roof spaces, underfloor spaces, ladders, scaffolds, elevated work platforms, trenches, pits, tunnels, and confined spaces. Reduced mobility increases risk. A worker may be forced into an awkward position. A worker may not be able to move away quickly if something goes wrong. A worker may be more likely to make accidental contact with live parts. In simple terms, when movement is restricted, the controls must be stronger. The worker's body position, access, escape path, lighting, and rescue arrangements all need to be considered before work starts. Clause 4.3.6. Illumination. Clause 4.3.6 explains illumination. Work areas must have lighting that is adequate and suitable for the work and for emergency evacuation. Poor lighting can lead to mistakes. It can make labels difficult to read. It can make terminals difficult to identify. It can increase the chance of slips, trips, incorrect testing, or accidental contact with live parts. Lamps should also be protected against breakage. In simple terms, the worker must be able to see clearly enough to do the work safely and leave safely if an emergency occurs. Clause 4.3.7. Batteries and DC supplies. Clause 4.3.7 explains hazards from batteries and DC supplies. DC means direct current. Batteries and DC supplies can create several hazards. These include arc flash, electric shock, toxic fumes, chemical hazards, mechanical failure, and fire. Before working on or near batteries, DC supplies, or electrical equipment that contains them, a risk assessment must be carried out. Suitable precautions must then be put in place. These may include following the manufacturer's instructions, using insulated tools, and using PPE suitable for the available incident energy. Battery terminals must remain protected by insulating covers where practicable while electrical work is being carried out on or near them. DC systems and batteries can deliver very high fault current. Short-circuiting battery terminals or DC conductive parts can create large arcs. Those arcs can cause personal injury, arc flash events, ignition of hazardous gases, ignition of other material, or fire. So batteries must not be treated as low risk just because the voltage may look low. A low voltage battery system can still release very high current. Clause 4.3.8. Electrical equipment producing high voltages, HVS. Clause 4.3.8 explains electrical equipment that can produce high voltages. High voltage, or HV, means voltage higher than low voltage. Some equipment can produce high voltage even where the supply arrangement may not appear unusual. Examples include cold cathode lighting systems, outline lighting systems, X-ray equipment, and open-circuited secondary terminals of current transformers. Some of this equipment can have open circuit voltages up to 15,000 volts. In practical terms, do not judge the danger only by looking at the incoming supply. The equipment itself may step up the voltage or produce dangerous voltage under certain conditions. Current transformers need special care. An open-circuited current transformer secondary can produce high voltage and place a worker in serious danger. Clause 4.3.9. electromotive force, induced voltage. Clause 4.3.9 explains electromotive force and induced voltage. Electromotive force, or EMF, can be generated when magnetic field changes occur through a surface. Devices that can generate EMF include solar cells, generators, transformers, and thermoelectric devices. EMF may also be generated near power lines, mobile phones, mobile phone towers, and similar transmitters. Some people who are sensitive to EMF may experience symptoms such as headaches, sleeping problems, depression, aches, or pains. Controls may include careful design of the work area layout, the use of barriers and signs, equipment that emits less intense EMF, and limiting the duration of exposure. In simple terms, not all electrical hazards come from direct contact with a live conductor. Induced voltage and electromagnetic effects may also need to be considered as part of the risk assessment. Clause 4.3.10. Material containing asbestos. Clause 4.3.10 explains material containing asbestos. Asbestos can be dangerous when it is disturbed and fibres are released into the air. Bonded asbestos that is well maintained may not present a significant health risk unless it is disturbed. Friable asbestos always presents a significant health risk. Work must not be carried out on asbestos unless it is done in accordance with a risk assessment and safe work procedures that capture asbestos particles or fibres. Risky activities include removal, drilling, cutting, and pressure washing. If an electrical switchboard or electrical equipment containing asbestos is damaged, extra precautions are needed. These may include respiratory protection, safety eyewear, and disposable gloves for visual inspection. A competent person may need to review, assess, and control the situation. Asbestos may be present in many electrical areas and items of equipment. This can include fuse boxes, switchboard mounting panels, meter enclosures, switchboard insulation lining, textile fuse carriers, conduits, cement sheets, underground pits, pit lids, aged wiring, and old insulation material. In New Zealand, workplace requirements apply around asbestos identification. Indication must be provided where asbestos is known or assumed to be present in a workplace. In practical terms, if asbestos may be present, do not disturb it casually. Stop, assess, and follow the correct asbestos process before work continues. Clause 4.3.11. Electrical equipment containing polychlorinated biphenyl, PCB. Clause 4.3.11 explains electrical equipment that may contain polychlorinated biphenyl, or PCB. Some older electrical equipment may contain PCB material. Examples may include capacitors, ballasts, transformers, and some switchgear. Where electrical equipment is identified as containing PCB, steps must be taken for safe handling and safe disposal. PCB material must not be treated as ordinary waste. It requires controlled handling and disposal according to the applicable requirements. Clause 4.3.12. Lightning. Clause 4.3.12 explains lightning risk. Lightning can present a danger to people working on electrical installations or equipment. During local thunderstorms, contact with metallic structures, metallic objects, electrical installations, or electrical equipment can be dangerous. Weather conditions must be considered when planning and carrying out electrical work. If lightning risk is present, the work may need to stop or be delayed until the risk has passed. Clause 4.3.13. Cutting cables or wiring enclosures. Clause 4.3.13 explains cutting cables or wiring enclosures. Cutting must not proceed until the correct processes have been followed and tests have proved that the cable is isolated before cutting. If isolation of the conductors inside a cable or wiring enclosure cannot be conclusively proven, the cable or enclosure must be treated as if it contains live conductors. A Safe Work Method Statement, or SWMS, must then be prepared. There is also an important warning. Non-contact voltage indicators and single contact voltage indicators must not be relied on to prove that no hazardous voltage is present. They must also not be relied on to prove that wiring or fittings have been de-energized or isolated to a safe state. A dual contact voltage indicator is required for this function. In simple terms, never cut first and hope it is dead. Before cutting, prove the cable is the correct cable, prove it is isolated, and use the correct test method. Clause 4.3.14. Removing out-of-service electrical equipment and cables. Clause 4.3.14 explains the removal of out-of-service or decommissioned electrical equipment and cables. Before removal, the electrical equipment and cables must be isolated from all sources of supply. Tests must also be made to confirm that the equipment and cables are de-energized. Old equipment must not be assumed safe just because it looks abandoned. A disconnected-looking cable may still be live. An old switchboard may still have a hidden supply. A cable that is no longer in use may still be connected somewhere. So before removal, isolate and test. Clause 4.3.15. Control measures when leaving work unfinished. Clause 4.3.15 explains how to leave a work site safe when the job is not finished. The work site must be left safe for access by other people. Exposed conductors should be terminated in a way that provides suitable protection, including IP2X protection. They should also have mechanical protection or restraint. Safety or information tags should be fitted where needed. Barriers, barrier tape, or other suitable methods should be used to keep unauthorized people out of the work site. Relevant people must be told that the work is not complete. They must also be told about any potential hazards. Precautions must be taken to confirm that the electrical installation or equipment cannot become energized unexpectedly. Switchboards and equipment must be clearly and correctly labeled to show their status. If another worker will continue the job, enough information must be provided so the work can continue safely. This includes a proper handover procedure when the work continues over a change of shift. Unfinished work can become dangerous very quickly if it is not controlled. Before leaving the site, make it safe, label it clearly, prevent unauthorized access, and communicate the hazards. That brings us to the end of Section 4 of ASNZS 4836. This section shows that electrical safety controls must match the specific situation. Some work needs a safety observer. Some work needs isolation, barriers, insulating covers, insulated tools, special PPE, a permit, or a formal handover. Some work must stop until the risk can be controlled. So always look carefully at the actual hazard in front of you. Choose controls that match the risk, and do not continue if the work cannot be made safe.